Good afternoon, YouTube. So this is a project I built about 6 years ago. I guess I called it a light bar. The idea with this is I have a AC power cord coming in here, and then I've got 4 ceramic light bulb sockets, and each one here has a switch that I can turn a particular socket on or off. I've used this for a couple of projects. One is I used it as a dummy load for testing my AC power inverter, testing efficiencies at various loads. So the idea is I could put in maybe a 150 watt bulb and a 100 watt bulb and a couple other light bulbs, and then I could turn on a 150 watt load, I could turn on another 100 watts. So then with that I could vary the power that this dummy load dissipates. That worked pretty well, and then I also use this for testing various light bulbs, like LED light bulbs side by side, and I could change this out. Right now I have a Z-Wave smart plug in here that this plug I can turn on and off remotely, and when it's powering this light bar it also monitors the power consumption. Earlier I had a light dimmer in here, and I used that to test various LED light bulbs. So I could set, say, 10% dimmer, turn on this bulb, see what it does, and I could turn on this other bulb, see what it does at that same level, turn them both on, have 3 or 4 bulbs in a circuit, just testing out how the dimmer works. I haven't used this too much recently. I think the last time I used it was a couple years ago. You can see it's a little bit dirty. So I had an idea to change this slightly, go back to like when I had a light dimmer in here. So I picked up a new light dimmer. This is an in-wall version, but instead of having actual light bulbs, what I'm using instead is one of these ceramic heat lamps. So I picked up like 4 of these ceramic heat lamps. They have a heat element in here that gets hot. They're 150 watts, and you have to use these with ceramic sockets. They warn not to use them with the plastic ones, so I can just swap these out. Like I said, the original design was set up so I could change load by switching lamps on and off. Then I had the Z-Wave receptacle, which I could turn the whole thing on and off. But what I want to do is replace that with this light dimmer, have that Z-Wave controlled, and then be able to run all 600 watts of these lamps through the dimmer and be able to control it from 1% up to 100%, or roughly from 6 watts up to 600 watts, and have that computer controlled. So I'm going to remove this smart plug and replace it with this dimmer here. Line and load, neutral, and a traveler. I don't need the traveler. There's your ground screw, so I just have to hook up the line, the load, and the neutral, and we should be good to go. Okay, I think I got this figured out. Had to look in the wiring diagram in the instructions, because both the input or line terminals just say line. They don't say which one is the load. But if you look here, here's the switch. This is the end with the ground screw, and this is the end that goes to the load. And then the incoming power goes to the screw that's opposite the ground. So I think that'll go. I just have to shove everything back in there. I've been following the Electrodacus group on Google Groups page, and there's a lot of the people using the SBMS, solar BMS system, and a lot of them are doing what they call diversion loads. A while back, Dacian had come up with a digital DMPPT setup. It was basically some solid state relays that could switch solar panels from charging the battery to running a diversion load, like a water heater is pretty common. So you'd put maybe some 24-volt water heater elements in a hot water tank, and then you would dump the excess power into those heat elements and heat your water. Well, I have a gas water heater that uses about $1 of gas a month, so I don't have any real need or ability to actually use anything for water heat. But I was thinking this could be a diversion load for my solar power system in the winter. When I have excess power, I could just dump it into these heat lamps and radiate the heat inside the house and get some additional heat out of it. So my SBMS 120 isn't necessarily set up to do that. My thinking is I've got the AC power inverter. It's a hybrid inverter, and I have it set up so that there's the load, there's the battery, and then there's the grid. So I want to be able to send charging power to the battery and the load first, and anything extra will get used up by this device in the winter. Figure I would repurpose this thing here, and basically the same thing I was using before, except now it's going to all be automatic and be controllable, like down to 6-watt increments roughly. But yeah, we'll see how this thing works. I got to get these wires stuffed in, get everything packed in there, and then we'll see about hooking this up to my Z-Wave system, and then see if we can get this thing working as sort of a diversion load to use up excess power on my solar power system. So stay tuned for that follow-up video, and as always, thanks for watching.